From the unit circle, we're going to take a look at the sine function. Remember, for the coordinates, and you see the ordered pairs, the first coordinate is for the cosine and the second coordinate is for the sine. So if we're looking at 0 radians, and we're looking at that 1, 0, remember sine would be 0. So sine starts at 0. When we reach pi over 2, sine has gone all the way up to positive 1. When we reach pi, sine has returned to 0. At 3 pi over 2, sine has gone all the way down to negative 1. And then at 2 pi, we've returned to 0. So let's take a look at our friend sine wave here. Of course, when it starts out, it looks like the slope is a positive 1. When we hit the maximum at pi over 2, it looks like the slope is 0. Pi units. Sine again returns to a value of 0, and it looks like the slope is negative 1. Bottom of the unit circle at 3 pi over 2, looks like our slope is back to 0. And we've completed one trip around the unit circle. It looks like the slope again is positive 1. All right, so 2 pi is a little bit more than 6, right? 2 pi is about 6.28. Again, relative maximum, slope is 0. Looks like we're back to a slope of negative 1. Relative minimum, we're back to a slope of 0. Second complete trip around the unit circle, we're back to a slope of positive 1. So what are we looking at? It starts at 1, slowly goes to 0, all the way down to negative 1, back to 0, and then all the way back up to positive 1. We're looking at the graph of cosine, aren't we? Cosine starts at positive 1. Right? 0 radians, cosine is at positive 1. So if I look at the graph of y equals sine of x, and I look at the slope of that graph, and plot the slope, I actually get the graph of cosine of x. So if I have y equals sine of x, and I want to take the derivative of y with respect to the derivative of x, I end up with cosine of x. Now what if I start with cosine? Well, again, at 0 radians, cosine has a value of positive 1, right? Cosine starts at the maximum. Well, looks like the slope is 0, negative 1, 0, positive 1, 0. That's one complete cycle. Let's do another one. Negative 1, 0, positive 1, 0. 2 complete cycles of cosine. Well, that's not sine, because while sine will start at 0, it would then go up to positive 1. It wouldn't go down to negative 1. So instead of sine of x, we're looking at negative sine of x. So if I start by looking at y equals cosine of x, and I look at the slope of that function, and plot the slope at each point, I end up with y equals negative sine of x. Right? So if y equals sine of x, the derivative will be cosine of x. If y equals cosine of x, the derivative is negative sine of x. Now, if I'm looking at y equals negative sine of x, well, I know derivative of sine should be cosine, but there's a negative in front. So if the original function is y equals negative sine of x, the derivative will be negative cosine of x. If we start with negative cosine of x, well, if I take the derivative of cosine, I should get negative sine. But there's already a negative. So negative negative comes out positive. So if y equals negative cosine of x, the change in y with respect to the change in x will be sine of x. Okay, now for some examples. The coefficient of 5 is just going to sit there because that's what coefficients do. Derivative of sine is cosine, so there I go. If the original is y equals 5 sine of x, the derivative will be 5 cosine of x. Ooh, get to use the power rule, right? Because I've got a function, sine of x, that's being raised to the third power. So that exponent of 3 needs to go out in front. Come out in front exponent. My new exponent is going to be a 2. But now I have to peek inside and take the derivative. And inside I see sine of x. Derivative of sine is cosine. So the derivative will be 3 sine squared of x cosine of x. Hey, let's use the product rule. All right, I'll leave the 5x squared alone. Derivative of sine of x will be cosine of x. Then I got to put a plus sign. This time I'll take the derivative of 5x squared to get 10x, but I'll leave the sine of x alone. Now if I was wild and crazy, I could factor out a 5x, but those are not like terms, and so I'd probably be content to say, hey, let's just leave it like that. Trick question. Y equals sine squared x plus cosine squared x. Let's pretend for a moment that I don't see what's going on, and let's just take the derivative. The 2 needs to go out in front. So I get 2 sine of x, but then I got to take the derivative of sine, and I get cosine because I have to use the power rule. Plus, again, that 2 is going to go out in front. So I get 2 cosine of x, but then using the power rule, I got to take the derivative of what's inside, and the derivative of cosine of x will be negative sine of x. So I've got 2 sine x cosine x. Let me see, I've got a positive times a negative. That's going to come out negative. So simplifying this a little bit, I get 2 sine of x cosine of x minus, and then there's a 2. There's a sine of x, there's a cosine of x. I get 0. Told you it was a trick question. What is sine squared x plus cosine squared x? For any value of x, of course, that is 1. Right? That was our basic Pythagorean identity for trigonometric functions. Sine squared theta plus cosine squared theta had to be equal to 1. And of course, the derivative of any constant number is just 0. How about that? Trick question.